Right, so now let's have a look at question number 5, which is trigonometric functions and what identities, double angles, and all of those things. Now, 5.1, it says to us, simplify the following expression without using a calculator. This is a restriction. This is what you should do. You should solve this. You should simplify this, meaning you're going to have to break it down into simpler form without using a calculator. So let us rewrite 5.1. So we have sine of 90 degrees, subtract x, multiply by 10, 360 degrees, subtract x. Okay, let me redo this by creating enough space over there. I have sine of 90 degrees minus x, multiply by 10 of 360 degrees minus x, subtract 2 sine of 180 degrees plus x, right? So this is a question that we need to solve by simplifying it. So then how are we going to simplify this? We're going to reduce these expanded identities, right? So we know that we have learned what you call a cast diagram. A cast diagram, it's simply, we can make use of it to reduce these expressions that we see over here. So to reduce this sign 90 degrees minus x, you're going to ask yourself the simple question. 90 degrees minus, it is found in which quadrant? You can draw your mini Cartesian plane like so. Here we have 90 degrees. Here we have 180. Here we have 270, even though we don't work with 270. And here we have 360 degrees. And this one at the top, it will be 0 degrees. So 90 degrees minus is when you go back from that angle. So it is in the first quadrant, right? So in the first quadrant, since well it is 90 degrees minus, all trigonometric functions are positive based on the cast diagram. So cast, recall that this A simply means all. So all trigonometric functions in the first quadrant, we say they are all positive. So 90 degrees minus, you're going to have positive, right? Because sine, it is positive, or sin, however you want to pronounce it. Sine, it is positive in the first quadrant, so we're going to have positive. But because we have 90 degrees minus over here, our trigonometric ratio will change to its cofunction. The cofunction for sine, it will definitely be cos. So we're going to have positive cos x. And then now we move to the second one. We reduce it. We have 360 degrees minus. 360 degrees minus, we go back. When we minus, we go forward. When we add, 360 degrees minus, it is in the fourth quadrant. In the fourth quadrant, our trig function, which is 10, at this point, it is negative. So I mean, we're going to have negative. I'm putting the bracket over there because sometimes you can make mistakes by thinking you are actually looking for the difference between these two expressions. So it's important to do that with bracket. So 360 degrees minus, it is in the fourth quadrant. So tan, it is 10, it is negative in that quadrant, so we're going to have 10x. Then minus 2. Now 180 degrees plus, 180 degrees plus, it is in the third quadrant. And in the third quadrant, we know that sine, it is negative, only 10. It is positive in the third quadrant. So since well sine is negative, then we're going to have negative sine x. Then now let's work it out. So negative by positive, we're going to have negative cos x. And then recall that the 10, it can be changed to its quotient identity. We know that the quotient identity for 10, it will be sine of x divide by cos of x, right? The reason why I'm changing this because I can see that automatically this cos will cancel with that cos. And then here we're going to have negative by negative. That will give us positive 2 sine of x. And then this guy and this guy, they fall off. This multiply by that, we're going to have negative sine x. Then there we have positive 2 sine x. And these, we can work them out algebraically. We can see that these are more or less of being the like terms. So this plus this, most definitely it will give us positive 1 sine x. Therefore, this will then be our final answer to 5.1.